Okay, so here is the wire nuts and pigtails. I'm going to quickly touch on this topic, and also please watch that video. Let me see if I can pull up the playlist, our playlist right here. So here's our YouTube playlist. It's beginning to get populated as we go along, of course. And here is the two videos I want to bring your attention to. One is this one here is the lab 3 that you should watch before coming to lab at least. And that covers most of the topics that have to do with the twist on wire nut connectors. Mm, And also, I have placed, this video is not by me, but it's a recommended helpful video that would prepare you, sort of give you some idea for the next lab 4, and it's how to make a box offset, because we're going to bend we have to bend the pipes or the conduits into two box offsets, one on each side, in order to connect two boxes. Right. So I'm going to give you a demo. We're going to give you a demo in class on how to do that quickly. But watching this video right here is going to help you with some sort of idea of how to make a box offset. And box offset is basically a basic offset, except it's not as severe as regular offset, if I can use the word severe. Um, and you're going to get some sort of idea of what you're dealing with. Also, from now on, I will be throwing in bits and pieces as far as pipe bending. The pipe bending, I'll tell you this, even if you work 20 years in the industry, there is always going to be something new for you to learn when it comes to bending conduits. So whatever I'm going to give you in this timeline that we have with each other for this class is never going to be enough. But also, whatever I'm going to give you is going to be quite helpful. And the rest of that is basically, as you go along, is your life experience when it comes to well, the specific topic of bending conduits. Um, I think, I'm pretty sure that after you leave this course, after you're done with this course, um, you're going to have a pretty good idea of, as far as getting yourself started with at least some of the basics, and then from then on, is, as I said, it's just going to be life experience. What I'm preparing right now is, I'm in the midst of doing that, is this here, and once I'm done with it, I will release that. Oh, my mouse is getting funny. All right, so here is the sticker I'm working on. I'm trying to recreate the sticker that is on the ideal pipe bender, right on the handle of it. I was trying to find some printout of it, and I couldn't find it on the internet. So I said, okay, you know what? I'm going to recreate that. So I'm halfway done through it. So I still have a lot of slots to fill. And once I'm done, I'm going to make a nice document, and I will release that for you with some explanations on how to use that. And it looks a little bit intimidating when you look at it, but once you get the idea of how it is done, you're going to find that extremely helpful when it comes to the topic of bending pipes. All right, so that's as far as that. And let's bring our attention to the pigtails. So as I said, please watch these videos, and some of them are going to answer some of your questions. Some of them give you some knowledge when it comes to the topic of the pigtails and wire nuts that are associated with that. And sometimes I wouldn't be surprised if after watching some videos, you are going to have some additional questions. So by all means ask, and I'll also try to, from now on, I will try to throw in bits and pieces when it comes to do that, because connecting wires and doing proper connections is extremely important. Well, first for the functionality of whatever system you are connecting, but also that has to do with the safety. You don't want to start a fire. So as you noticed, we are putting a great deal of attention to the well, the screw terminals and otherwise terminals, like for example, the pigtails. We're putting a great stress on those connections being done properly. If you are still struggling with some of that, please either send me an email or stay after the lab and ask me to show you some of the stuff, because maybe there is some little thing that you might need a little assistance with some of the connections. And I think it's extremely important for you to do proper connections, and it might just be a matter of a couple of minutes of me doing a little bit of correction, and that can go a long way. So please don't be shy. Stay after hours. Sometime after, when you're done with your lab, please stay and ask me to help you with some of that if you're still struggling. I want you to get a good head start when it comes to this, because from now on, after you leave this class, you're going to go to the next class, next course, that you are going to have to use this knowledge to educate yourself further. All right. So okay. So watch these videos here. Now, here's the question that I'm talking on the video, that the lab preparation video, that is to pre-twist or not to pre-twist. It's a forever ongoing debate. Some professionals, some tradespeople, they swear by the twist, and some they swear by no twisting. Let the connector do the job. Well, so it's almost like two camps going on. Some people are for twisting, and some people are against, not against twisting, but it's not that necessary. My perspective on that is that it is a really extremely good idea to twist rather than not to twist. And as I'm explaining on the video, especially when you have more than 3 wires being connected by one of these connectors. And here's the inside of it. If you have a pre-twisted, you have a good structural integrity when it comes to those conductors. If you have more than 3 conductors, and if you don't pre-twist, there's a chance that the 4th connector is going to be right in the middle, and it's going to be embraced by those 3 other ones, and it's not going to be held by the thread of the twist on connector. It is just going to be squished, and it's going to be held by compression by the other conductors. I would rather have it so at least part of the conductor is being grabbed and held by the thread of the connector. Then you have a pretty good connection going on. If you don't, that wire can, if I may say that, can wiggle itself out sooner or later, one way or another. Right? So my perspective on that is, I would say I belong to the club, quote unquote, that say yes, please pre-twist, and I would pre-twist even if on the box. Sometimes on the box with the connectors that are being sold, sometimes it is going to say no, it's not necessary to pre-twist. Even then, I still pre-twist. Okay, it's better safe than sorry, and I think it's a better connection when you're pre-twisting. Okay? Now, of course, there could be some different people that would say that would have arguments of why not, but I belong to those people who think yes, you should be pre-twisting those wires. All right, now when it comes to capacity of the connector, some of them, well, since one size fits all, well, that's a pretty bold statement. There's an asterisk that goes with it, and I didn't photograph the part of that where the asterisk is. Of course, it's not one twists all. I'm pretty sure the asterisk refers to that part when when things are being explained a little bit further, and I have a magnification of that at the end here. So here's I took a picture of the specification. Oh yeah, look, here's the asterisk. All right. So these connectors are listed as pressure type wire connector. There are different type of connectors. There are screw terminals connections. So it's a different type of connection. This is called pressure type connection. Later on, when we study next semester, when we study the data infrastructures, I think the course is called network cabling. I'm going to introduce you to another type of connection. It's called insulation displacement connection. Also known as IDC, insulation displacement connection, and that is used not in service wires, not in where the power goes through, but in signal wires such as data wires. Okay, but that's later. Let's take a look at what this sticker says on this box here. This is listed as pressure type wire connector for use on solid and or stranded wire combinations. One thing I'm going to say about this, and I'm pretty sure this opinion is going to be shared by many people in the industry. I am not really too fond of using these type of connectors when it comes to combination of solid and stranded wire, simply because the solid wire is more structurally solid, okay, and the stranded conductor is always going to be softer than the solid conductor. So what's going to happen is going to create a wraparound situation when the softer wire or conductor, which is stranded, is going to wrap itself around the straight solid conductor. And I'm not really enthusiastic about that kind of situations. It's still legal, but you gotta be really careful, and you gotta find your own way of making sure that there's a beautiful, nice, and solid connection when it happens to combining solid and stranded wires. The the mm, the problem also can be when you over twist too much, that thread cannot actually bite into the strands of the stranded wire and start cutting them off. So as you go along, you're going to have to find your own way of making a proper connection, and that comes with time and experience, right? So here's the first sentence. So that's that. Okay, we went over that. Now it says minimum, this particular connector, which is in this box, which is what we're using. Oh, there's a free knife inside. Well, good luck finding that right now. It's almost like a free toy in the cereal box. But the size, it says, well, one size fits all, but, okay, now here's the but, okay. So it's supposed to be used minimum of 3 22 gauge conductors and maximum of 3 10 gauge conductors. So 22 gauge conductor, when you're in the other subjects, you are connecting the electronic parts on the breadboards. The 22 gauge wire, solid wire, is mostly that's being used for that. So that's the thickness of the 22 gauge wire. So minimum, you have to have minimum for this connector to be effective and safe. You should have minimum of 3 22 gauge wires if you use 22 gauge wires, because if you don't have minimum of what is supposed to be in that connector, this thread might be too big to actually grab on to what you have and you were trying to connect, and you're going to try to twist it and it's never going to grab things. It's never going to grab the copper properly, so you're not going to have a proper connection. You're going just to have like the connector sitting on top of the wire, and if you just tip it over or shake it, it can fall off. All right, so minimum 3 of those. If it's less, then you might not have an effective connection, and maximum of 3 10 gauge wires, and 10 gauge wires are going to be thicker than 22. Remember, as the gauge number goes up, the thickness goes down. So This would be thin wire, just like the hookup wire that you're using on the breadboard labs. And this will be gauge 10 wire, which would be quite much thicker than the 22 gauge. So you can also have, too much. And if you have too much, then there's going to be too much for the thread to grab onto. And you're not going to get a full connection because this here is not going to be, this thread diameter is not going to be wide enough to grab on if you're trying to put too many wires in there, or the wires that are too thick. Okay. I'm just, where's my mouse? There you go. What else does it say here? We have this, and the most applications in okay, so minimum combinations of the wire. So you get some possibilities here. Minimum of 322 gauge or maximum of 310 gauge, and most applications in between, including you can have 1 to 3 12 gauge conductors. Right? And why does it say 1? Why would you want to put a connector on just 1? You're not connecting it to anything, but why do we still put the wire nut onto that? Why do we put the connector on it anyways? Well, if you remember, the rules are, and at some point when you study the code, you're going to find out that whenever you're designing a system or the wiring system, you are supposed to include the neutral conductor in every box that that's part of the system. Whether the neutral wire is supposed to be used at that moment for this system that you're connecting or not, you should have that neutral wire in there. Right? And I think it's an excellent idea that the neutral wire has to be included. And as you go along, you will see why. Because sometimes you're going to retrofit things. Sometimes you're going to change things. Sometimes you're going to take off the old equipment and install maybe something that's upgraded or newer piece of equipment, and it's going to require that you use that. So instead of having to pull another wire where the whole thing is constructed, it's covered by drywall and everything, so it's going to be a major thing to add wire. Why not have it there? So the neutral wire, and there's probably some other reasons as well, but I think it's an excellent idea. So if you have a situation that you have a box that is not going to use the neutral wire, you still have to have it. And if it's the last one in the run, then you're going to end up not in a pigtail, but just going to end up with one loose end that is the neutral. And what you're going to do, even if you cut that, and even if you don't strip it, on the tip, there's that exposed little piece of copper. And that thing can move around and it can touch. It can touch the electrical box, it can touch other devices. So we should always cap that just to make sure that there is no possibility of that copper to be exposed and touch something else. So that's why sometimes we can put those connectors on one wire, right? So 1, 2, 3 12 gauge should not have more than 3 gauge 12 conductors in there. Right? Or you can put 4 number 12 conductors and it says solid only. Right? Then what else? You can have 1, 2, 5, 14 gauge conductors. Remember when we were doing the pigtails in the lab? Some of us already have done it, and some of us who already done it, we are making a pigtail consisting of 2 conductors. We're making a pigtail consisting of 3 conductors. Can we see with my fingers? There you go. And we're going to make one that consists of 4 conductors, and we're using 14 gauge. So we are good with this type of a connector because we're doing 4, maximum of 4, 14 gauge. And then we can add on width. 260, so it's a 4, the W stands width. So you can have 4 14 gauge with 2 16 gauge conductors, and it's still going to fit in there. Or you can have 3 gauge 12 with 3 18 gauge conductors, and so on and so on. So so always look at some of that. But even if you don't have that, if you just get like a loose bunch of loose connectors, and the colors, well, don't I will never go by the colors of the connectors, because these type of connectors are being produced by more than one company, and the company as a corporation, they always try to introduce some sort of way, their way of doing things. So they're going to say, okay, here's going to be orange, and it's going to be smaller than yellow, and then there's going to be blue, and there's going to be black, and you're going to try to remember all that thing. And maybe something's going to be produced by some other company, and they're going to have maybe a different color scheme. So I just try to, well, for the most part, I'm not rejecting that color scheme, but I'm just taking it with a grain of salt a little bit. Uh, the best thing is just to look at the box that is the connectors are being sold, and look at the specifications of that. Even if you don't have it, you're going to, as time goes along, you're going to see whether the connector is grabbing things properly or not. So that's as well, right? Um, but I'm going to refer you to read the specifications, always read the specs on things that you are using, just to make sure that you are, well, safe and legal. Right? Now, so that's the specs of this connector, and the rest of that is in French. So if you prefer to learn that in French, more comfortable in French, then you read the second part. It's the same thing, but this one is in English, this one is in French. Because we're in Canada, we have two official languages. All right, so that's as far as it. Then there's some rest of the specification. I'm not going to go through all of that. It's pretty much self-explanatory, and read it. And if it's not, so there's some voltages, temperatures, and all that paraphernalia that goes with it. All right. Okay, so that's as far as the wire nut connectors. And the rest, some of us already got during the lab, and the rest of us are going to experience that during this week, because we're still during the um, Pigtails lab. All right. Now, also, just a reminder, please watch the other video on our the last, well, as of today, it's the one, it's the last position, and it says how to make a box offset. It's a very short video, but it goes a long way. And there's that particular video that I chose from YouTube for you to watch, because it gives you the proper basics. There are also tons of really good videos or instructional materials, some of them better than others. Some of them teach you bad habits, some of them teach you some good shortcuts. But please, when you're learning this, get the basics out of the way first. Learn the basics. Then later on, as you get more comfortable, you are going to come up with your own ways of doing things that are more economical, more efficient, more effective, or whatnot. But get the basics first. Right? All right. So, and here's that video right here on our YouTube playlist: how to make a box offset. All right. Now let's continue on with the ladders. Right, we're going to talk about the ladders. Let me just bring it to the full screen here. Uh, scaffolds and ladders. We're going to talk about ladders first, and today we're going to get through the first half of the ladders lecture, and next time we'll see each other, it's probably going to be, I think it's Friday. We're going to continue with the second half of that, and the next week we're going to talk about the scaffolds. Right? These are two bit longer presentations here, and these are going to be ready for you to download soon. Okay, so scaffolds and ladders, safety training. Okay, section 1, overview. Let's take a look at that. Okay, so by the way, this is an example, a small example of a scaffold, and this is a small example of a ladder. All right, okay, let's keep going here. First things first, safety, right? Just to bring some awareness when it comes to safety. All right. Fatalities by event or exposure. What is a fatality? It would be an accident or event that would cause somebody to die. And yes, I'm not going to candy wrap anything just to, to be gentle or whatnot. I want you to not get hurt. I want you to not die during your work, because it's not a good thing. It's not a good idea, right? So fatalities, it's, yes, I'm going to use the words deaths, okay, by event or exposure. And here's a pie chart of what kind of fatal accidents have happened. So these are the accidents, and it's these are statistics, and there could be whatever the statistics are, wherever they're from, they are going to be very similar wherever you go, and pretty much whenever it is. Okay, so this is from 2003 to 2003 to 2006, but by the NHAB, residential construction industry, right, in the States. So here's here's the breakout of things. What is the number one of fatal incidents, right? Well, it would, or accidents or occurrences. Look at this. Falls takes the cake, 45%. That's a huge, section of the pie. What's the next one here? 18% is contacts with objects and equipment. That's a big one too. Exposure to harmful substances or environments. That's also not a small pie, piece of the pie, right? Then transportation accidents also was 14%. And assaults and violent acts, 3%. It would be nice if there was 0. And fires and explosions, 2% of the whole fatalities that resulted in as a result of accidents. Okay, so now since we have the falls, and since we are dealing with ladders and scaffolds, so this would be like elevation devices, so that would elevate yourself from one plane to another. You climb on the ladder, you climb onto the scaffold, and you're working on heights. Okay, and whenever there's height, there is the well, the risk of you falling down. So let's concentrate on that in order to, if possible, to eliminate the whole thing to 0. That's the goal. Of course, it will be the goal. All right. So if we take a look at just the falls, right, let's take a look how that breaks apart. Like that breaks down. Okay. So this pie chart here is just the falls. All right. So 40% is the biggest piece of the pie, again, is falls from a roof, falls from roofs. Then the next one is falls from ladders. Yeah, it's less than 40%, it's 22%. It's still, well, this pie chart, this piece of the pie chart, that basically reflects people who have died. Okay, so it's not something to be ignored. It should be taken extremely seriously, because you know what, your life depends on it. Okay. Next thing here was 15%. We have falls from scaffold, not as many as from the ladders, but still a lot. That's 15%. 15% too many. 15% too much. Okay, 9% falls to a lower level, unspecified or not elsewhere classified. So other falls. Right? Falls from non-moving vehicles. That's 12%. What is it? 48% here. Falls from, okay, so we're that, and falls from building, grinders, or other structural steel. So from, framing, that will be that will apply mostly to like welders that are welding things on frames and things like that, when you have to walk when you have to work on some framing structures. And then here's the 1% falls from other falls, again, falls from the same level. and falls down the stairs or steps. Okay? I'm going to stop here for a sec and bring attention to this. Whenever you're going to work on the construction site, that is basically legal in where we are, which is in Canada, you are going to be approached by the safety officer, and the safety officer is going to give you a safety briefing uh, during the first day that you're on this the job site. Now, whether you came here to do a little tiny bit of a project, one day in, one out, your boss, or you, if you're the owner of the company, or if you work for yourself, you're going to be notified by the construction company that you have to have that safety briefing by the safety officer that's designated to that site in order to be able to walk in there and work there. Right? So, if it's a longer project, if you're going to spend maybe 1 2 weeks or 3 months on that, one day is okay, you just write it off. But even if you just come for one day, you still are going to designate one day before, so that job is going to be 2 days for you in order to get the safety briefing. Otherwise they will not let you in on the construction site. So when it comes to falls from the same level, some say, how can somebody get hurt if they're falling from the same level? Well, in one of the safety briefings that I had, it was one of the, I think, well, it was nice few years ago. I was doing some wiring for a company that got hired to work on the St. Joseph's Hospital in Hamilton, Ontario. Uh, mm, and of course I had to go through the safety briefing first, so that first day was a write-off as far as doing the job, but it was not a write-off for your own safety. So I think it's a good idea that they do that kind of stuff. And after watching a bunch of videos and having discussions and instructionals by the safety officer that's there, mm, there's going to be, usually there's a little bit of evaluation going on, so they can ask you some questions, they can talk to you, and when they talk to you, they also try to get the feel of what kind of a person you are you danger to yourself and others and stuff like that. So and then little conversation, and sometimes they're going to ask you some questions just to make sure that you comprehend the idea of what they were trying to relate to you. All right, excuse me. So the question that I was asked just before the person just let me continue with my work was how high do you have to be to get hurt if you fall? And my answer to that was, well, he says, well, do you have to be 2 feet off the ground, 3 feet off the ground, 15 feet off the ground? How high do you have to be considered dangerous? How high do you have to be? If you fall, you're going to get hurt. Well, my answer to that was, I said, you could be sitting in a chair, in the office chair, and you can fall in a certain way and you can get yourself seriously hurt or even killed. Right? You could be sitting on the ground, and if you fall onto something, or you fall on an even flat surface, if you fall a certain way, you can also get severely hurt. So there is no threshold of how high do you have to be. Now, of course, mm, the risk of the severity of the possible injury goes up the higher you go, because the higher you go, the harder you fall. That's the good old saying kind of a thing, right? So I just want you to be aware of these statistics, right? You are just at the beginning of your career. You haven't even started your working career yet. And I want you to have long, happy years of and enjoyable years of working and supporting yourself and your families. Okay? So that's why we have this awareness here for you. Right. Section 2 of this presentation is ladder and stairway safety. Okay, so what is that? Let's take a look at the common ladder hazards. Well, number one, it says improper setup. Well, You could be the most conscious person and most careful, but if you're working or walking on something that is not properly set up, then well, things can happen. And usually when things happen because of improper setup, usually things that happen are not good things that happen. All right, so in proper setup, you need to know how to set things up properly, whatever the equipment is. And sometimes it, depending on the complexity of the equipment, sometimes it's just a matter of reading a little short manual or instructions, and sometimes you have to get trained to use some specific equipment. But take this seriously. You know what? It's not exaggeration. Your life actually depends on this, right? Now, portable, another one, common say, ladder hazards that things can happen. Portable ladders not 3 feet above the landing surface. We're going to, couple slides down the slideshow here, I'm going to talk about what a landing surface is. So I'm going to come back to that. Not securing the ladder correctly, right? Well, it's kind of goes together with the setup. So the setup is more of how this thing is put together, um, and this one is more like you know, the ladder is against something and it's not secured properly, then it also can, you know, the ladder can go down, and if you're on that ladder, you're going to go down with it. All right, so then also here is standing on the top two steps of a ladder. All right? We're going to talk about that as well. And overreaching when working from a ladder, that is also going to be explained. So after we go through the slideshow, when you download it, you can go back to the first slide and just kind of dwell on that and reflect on that a little bit more. Okay, so let's look at the typical step ladder anatomy, parts of the step ladder, just so we know what we're involved with. Yeah. So here is the top cap. Here's the last step. Here's the second last step. You're not supposed to have your feet higher than this step. This is as high as your feet go. If the safety officer walks, and they do, right, on the construction site, and if they see you um, standing on this step here, you can almost bank on it. They will, without any questions, without any explanations, they're going to just tell you to go home, and your boss is going to find out why you were sent home. Okay, they're just going to kick you off the site, and especially that. So if it's any higher than that, yeah, okay. Um, then what kind of other parts? So step ladder is one that that you use those spreader assemblies to spread those rails apart, and then use the steps to step on. Those at the back here, they are the rear braces. Okay, so we have the braces, and here's some of the diagonal braces. So over there, this is just a part of the construction to keep it sturdy. This is not to be used as something that we can stand on. So we can stand on this step, we can stand on this step, and that's pretty much it when it comes to this 1, 2, 3, 4-foot ladder. Usually those prongs are going, those steps are 1 foot apart. Prongs are in the extension ladder, these are the steps. Okay. So what else do we have here? We have the rear rails, we have the front rails, pail, shelf. It's just to put things on, but by no means you should be standing or sitting on that. If you ever try, you're going to find out why, and you're going to find out the hard way. And it's not going to be a warning, and it's not going to be a kickoff from the side. It's going to be a hard way. You're going to go down with that thing. So please don't try it. Then here's a spreader assembly. The ladders, step ladder should be fully spread, okay, in order to have to be considered as properly set up. If this thing is missing, or if it's not fully extended, the ladder is considered not safe, right? And well, I don't have to explain what can happen. Gravity is not really your best friend when you're falling down. Okay, so that's some of the parts of a step ladder. Okay. Now, choosing the right ladder. How do we choose the right ladder? Before stepping onto a ladder, think about these things. Wow. Okay, let's see. The duty rating of the ladder, which means what capacity can it hold? And we're going to look at some stickers, the next slide. It's all the information that has to do with that. Height of the ladder. Is the ladder too short or is the ladder too long or too tall? Condition of the ladder, of course, and the instructions unique to the ladder that you have selected. Okay, now let's expand on some of these here. The duty rating. According to the Canadian Center of Occupational Health and Safety, here are the duty ratings for ladders. So in this column here, here's the duty rating. It's the type of the ladder, sorry. Here's the duty rating, basically name of the rating. The suggested uses or designated uses, and the loads that the ladder can hold. So here is, according to the Canadian Occupational Center of Occupational Health and Safety, type 3 is the lightest duty. It's a type 3 ladder, considered to be a light duty, and it is meant for household use. Household use is that sometimes you need to replace a light bulb in your ceiling light, and then you take the ladder out of the closet, you step on it, use it, and put it back. And next time you're going to use that ladder, maybe it's going to be 2 months from now. So that's considered household use. It's not a continuous use type of a ladder. If you take that ladder to a construction site, you're going to replace that very quickly because it's just going to I'm using the metaphorical expression, is going to almost like dissolve under your feet and in your hands because of the construction site or commercial site or industrial site. It's not a household use. You can't even compare the amount of usage that this ladder is going to have to accommodate. All right, so then here's the type 2. And now, okay, so that one is rated for 200 pounds. Okay, well, I can't use that. I can't use that ladder. All right. Maybe later. I always keep promising myself, but then there comes Christmas and now there's holidays. So, but anyways, I can't use that ladder. Type 2 is considered a medium duty. This is what I would probably get, because it's also rated for commercial, but sure, you can use it for household use. And here's the thing, it's rated for 225 pounds. Sometimes I can use that and sometimes I can't, right? And that's all I'm going to say about that, right? Then there's a type 1. It's considered heavy duty. It's meant for industrial use, industrial or commercial as well. So that would be the ladder that you would probably get, a step ladder of the type 1. If you wanted to do some wiring on daily basis and you have to go up and down the ladder and move the ladder, set it up, fold it together and move it maybe 1,000 times a day, that would be the most optimal, because the heavier the duty of the ladder is, the heavier in weight. The ladder actually is made of more tough material and better material and more solid, but that also goes with the weight of the ladder. So yes, this will be the lightest one, and you can just pick it up with one hand, move it all the way, but it's not rated for such a heavy use. It's going to fall apart and you're going to keep replacing that maybe every 2 weeks. This one here is meant, that's probably the best optimal for industrial use. If you're going to do some installations or whatnot, this will be the lightest ladder you want to have. And it's supposed to support 250 pounds. I can definitely use that ladder. And it is supposed to handle a heavy usage putting it together, oh, not putting it together, spreading it and setting it up, folding it, moving it to a different side and a different spot. And when you're doing wiring installations or any kind of devices, you have to rise above the ground that you're standing on, mounting something on the wall that's higher, mounting something in the ceiling. Of course, ceiling is higher than the floor, so that would be the lightest one that you want to get. Right. Then there's that 1A, extra heavy duty for industrial use, supposed to handle 300 pounds. And then there's the 1AA, special duty rugged use. This would be the ones that when you see the either city workers or companies that are hired by the city or contracted out, uh, that are working on the communications wiring. So that would be the communications vehicles. And when you see those big yellow fiberglass ladders that sometimes it takes two people to carry it and set it up, this would be the double A ones, special duty rugged ladders. They are heavy to carry, they're heavy to set up, but sometimes you just have to have no less than that in order to be safe. So that's how we are classifying the ladders as far as um, the rating, okay, the duty kind of duty ratings. Now, from that, how do you get the information? Well, the ladders will have stickers. So here is a step ladder that we just looked at. Um, and here's a sticker that you're going to find that. Well, next time you're in a home hardware store or Home Depot or Rona or Lowe's or whatever, take a look at those ladders, find those stickers, see what information you can get from there. And this is an extension ladder. That is another type of ladder that we're just going to basically take a look at, and we're going to come back to it next time we see each other. So this one is rated, okay, 300 pounds. This one is rated for 370 pounds. All right. Then there's load capacity. There's load capacity, star performance. Yeah, okay. Duty rating. So here's that duty rating right here. Okay. Then the ladder size, and there's a phone that's ringing. Let me just wait for this thing to stop ringing. We're almost done, guys, for today. Just one more minute and we'll be fine. We'll be done. Okay, somebody picked it up. Good. All right, so this one here is the ladder size. So here's a 6-foot ladder. This one here is 1, 2, 3, 4-foot ladder. Okay, so 6-foot step ladder will have 2 more steps. Okay, so then maximum reach of that. So when you're standing on the ladder, what would the average maximum reach? So if you're standing on the proper step or prong, which would be not the 2 last ones, not the 2 top ones, um, then how is it that, considering average person's height and reach, how far you can reach up with that ladder? So here, and so this is one for this type of extension ladder, and this one would be for the, well, of course, it's going to be longer extension ladder. Okay, and then there's a highest standing level, so that's where you're going to have your feet. Okay, so this one here, see, 6-foot ladder, but your feet can only be at 3 feet and 10 inches. All right, and then there's that for the extension ladder, and the model ID number, and the rest is basically some logistic specifications that have to do with that. Now, remember when I was talking to you about the um, 3 feet above the landing surface? What is a landing surface? If you're standing here and you want to bring yourself up to here, this would be your landing surface. Right? And you can see that this ladder is extended 1, 2, 3 feet above the landing surface. So when you set up an extension ladder, so this is the difference between, we're going to talk about later on next time we see each other, when the anatomy of extension ladder. It has the steady part and it has the extension. So you slide it out according to what height you want to reach, and you kind of lock it into place. And that's how you use the extension ladder. And you can say there is a certain distance from the surface here that this ladder should be extended, not too far, not too close. There's a 1:4 ratio, but also, and we'll talk about that. And also, again, it should be secured it should be secured to the surface of whatever it is you're dealing with, and again 1 to 3 feet above the landing surface. So that's when I said, well, I'm going to come back to that. That's when I'm coming back to the first slide, or a couple of first slides that we had. Okay, so that's where we're going to finish today's lesson, and um, we're going to continue that next time we see each other. Okay, I hope I wish you to enjoy the rest of the week. Those weeks, as you notice, the weeks are beginning to go faster and faster. So this is the time for us to work on things, and there's no time to snooze. And if you're feeling that you are falling behind, talk to us. Please talk to us. Okay. All right. That's it for today's lesson. And as always, it's almost Friday, because every day is almost Friday. Have a nice day, guys. Thank you very much.